Hello, mechanical engineering students. I'm going to talk to you briefly about how to write your mobot design report and how this fits into other writing that you are going to do as part of your degree and the type of engineering thinking that you're supposed to display in your writing. In your writing class, you may have heard about the IMRAD format. IMRAD stands for Introduction, Method, Results, and Discussion, and it is the most common form of technical report writing, the most common form of engineering report writing. Now, this paper has a specific IMRAD variation and one that you will be using a lot in your Mechie course writing, and that's called the Design or Proof of Concept report. And so it just changes things a little bit. We still have an introduction, but then we have a big section on design that describes all of the design decisions, all of the creation decisions, and then an evaluation section or test results section. The names of these sections change. Different professors might call them slightly different things, but the content is the same. And instead of a discussion section at the end, we have a conclusion. Now, when you do your design report for this mobot project, you should think about it, and you should think about all of your technical report writing as shaped like an hourglass. And what I mean by that is that the beginning and the end of report starts off with broad questions, should be written so that somebody without a technical background can understand. And so no matter what kind of report you have, you want to start by stating what's the problem and clarifying what's at stake, why this is important, why we need to do this. In your mobot project, this would be very brief. I think you can do it in 2, maximum 3 sentences. The majority of your report, now this is kind of broad, and in the conclusion, you should sort of answer the problem that you set out in the beginning and say, okay, here's what we got. Here's how close we came to solving the problem that we set out. And here's what the next steps are. Now, so that's the beginning and the end. The majority of the report should be more narrowly focused on the design decisions, so on the algorithms that you programmed and the parameters that you coded. And you should really describe your process in terms of what you did, why you made these decisions, what was your rationale. And the test results section will likewise be narrowly focused and did the thing that you built work, and why or why not. So in a nutshell, this is the format, the design, not just of this report, but really for any type of design report that you have. Now I just want to show you briefly what a full-fledged design report would look like. Don't worry that this is small. I'm not expecting you to read it. I just want to talk about the format. This is from a paper in robotics where they are trying to design a robot that has a tail modeled on lizards that can right itself when it's falling. And I just want to point out the different sections. I want you to see how it has headings for introduction here. We'll go through, and every figure is clearly labeled with lots of sections. We have a section here for robot design, and then under this section, we have lots of subheadings. So here's the mobile robot platform. That was A. B is the tail design. And C is the sensing and feedback control. So lots of subsections when we talk about the design. Then they have an experimental result, or this is their test results, or their evaluation, where they're asking, did the robot work? How did the robot do when it fell? And in robotics, it's very common to include lots of figures or even videos. And then they have a section, and again, in this section, there's lots of subheadings, all the ways that they tested their design. And then they talk about conclusion and future works. When you write your paper, I want you to similarly get in the habit of using clear section headings and subsections, like we saw in that formal academic paper. And as you move from academic writing, writing in school, to more workplace, we do even more of these headings and subheadings. And this is called document design. And the goal is that it should really help people skip around and find different sections really easily. Because someone is probably going to jump, look at your results, and then they might be like, oh, how did they do the tuning? Or how did they do their speed control algorithm? So we design it so it's easy to find this information. Now you can do main level headings like this, or you can number them so that it looks something like this. You can also indent some of the sections so that your text kind of starts in, and this makes these main headings stand out. This would be more common in a workplace document than in an academic document. Now, of course, here we have a separate section for your reflection, to reflect on your learning. When you go into the professional world, you, of course, won't be writing these reflections, but it's a very important part of your learning and school process. Now, one last thing that I want to draw to your attention is something that you're going to be held accountable for in all of your engineering writing, is being very precise and clear. Engineers often tend to write in simple sentences that can't be misunderstood. This is a sentence that I copied from an otherwise very strong report. And I want you to see how this sentence has some ambiguity. Okay, so it says the algorithm checks each loop whether the distance read by the sensor was less than 10 centimeters. If it was, it stops. Otherwise, the loop keeps going. So the number of its in here adds just a little bit of ambiguity, requires a little bit more work. It would be more clear and precise to state what these are. If the value was less than 10 centimeters, the loop stops. Otherwise, the loop keeps going. This takes multiple sentences to clarify. That is fine. Also, the algorithm here isn't checking the loop. The algorithm's checking the distance. Okay, so I think what this should be is at the end of each loop, the algorithm checks whether the distance read by the sensor was less than 10 centimeters. If the distance is less than 10 centimeters, the loop stops. Otherwise, the loop keeps going. Now, this may seem like a small thing, but when multiple sentences like this get put in a document, then it becomes very confusing overall. Secondly, this takes people longer to read. If it were more precise, it would save people time. And people want to read your document as quickly as possible so they can go and do things and take actions based on it. So you want to be as clear and precise and exact, even if that means you need to write simpler, more straightforward sentences. Another reason that engineers are really so precise and clear in their language is if someone misinterprets something, that can cost money. It can lead to legal implications. So we want you, and every time you get one of these videos, we'll talk about another area of precision. But this is one example where we want you to be as straightforward and unambiguous. And anytime you're referring to it, see if you can replace that with an actual noun so that there's no possibility for confusion.